Yeah, welcome to VLSI Simplified YouTube channel. So today I want to explain you about the problems related to this logic gates and as well as some combinational circuits. So there are some few five problems are there. First problem we'll see just which of the following circuit in figure A to D is sum of products implementation of figure E. That means in this options, which is matching to this circuit. So I'll draw this. What are the I'm getting? This thing, but if you consider, so this thing, but yeah. So yeah, this is nothing but CD bar, and this one is EF, and AB is coming through the AND gate. So this expression is AB and CD bar, AB and CD bar plus EF, EF. So if you multiply, you are getting AB, CD bar plus AB, EF. So this expression we need to get. So that is X equal to this expression we need to get. Okay. So I'm checking from in the option A. Option A is this is the AND gate. So I'm getting this is A. Checking this. Yeah. So this I'm checking. This is nothing but A, B, C, D bar, E, F. Okay, again it is given to the OR gate. That means the input it tied together. So this is nothing but A, B, C, D bar, E, F. A, B, C, D bar, E, F. So this is not matching with this expression. So this is not correct option. And next one, I'm checking this one. This is nothing but A plus B plus C plus D, and this one is D bar. So it is given to the bubble D bar, and this is A plus B plus E plus F, E plus F. So E plus F, E plus F. So E plus F. So this is equal to A plus B plus C plus D bar A plus B plus E plus F. So this option also not matching. So this is not correct option. And I will check this option. This is normally A bar, B bar, whole bar, NAND gate. So if you apply DeMarcan's law, A bar whole bar plus B bar whole bar. So this is A plus B. And this is nothing but C bar D whole bar. So if you apply DeMarcan's law, C bar whole bar plus D bar, so this is nothing but C plus D. And this is E bar, F bar, whole bar. So if you apply DeMarcan's law, E bar whole bar plus F bar. So this is F bar whole bar. So this is E plus F, E plus F, E plus F, E plus F. Okay. So if you combine option, so I think so E plus F. So if you combine, This we are getting uh, so a plus b plus c plus d bar. So this is d bar. So a plus b plus c plus d bar c plus d bar c plus d bar plus next e plus f whole bar. So this option is not a match. So anyway, if you write this is nothing but you are getting so a bar b bar c bar d e bar f bar. So this option is the not match. So this option I will check. So this is nothing but A, B, C, D bar, and this one is A, B, E, F. So this is given to OR gate. So A, B, C, D bar plus A, B, E, F. So this match, these expressions to our match. So that means from this you can say that this expression is matching with D. The correct option is D. Okay. The correct option is D. So D is the correct option. So D is the correct option. D is the correct option. Okay. And next we will see next question. Which of the following logic expression represents the logic diagram shown? So if I see this, this is nothing but A bar, and this is nothing but B bar. This is A bar, B bar. This is AB, and this is equal to what? A bar, B bar plus AB. We know that A bar, B bar plus AB equal to what? A XNOR B. A XNOR B. Or directly you can see the option. So this is the A bar, B bar plus AB. So that means you can consider this as A dash, B dash also. So some textbooks they will call A dash, B dash, or some textbooks they will call A bar, B bar. Okay, both are same complement. So A dash, B dash plus AC. So that means D option is matching. D option is matching. Okay, D option is matching. D option is matching. Okay, and next, device is mostly likely A. So that means two selection lines are there. One data input is there, and four outputs are there. So from this, I can say that this is a demultiplexer. Okay, so many to one circuit. So it's a many to one circuit, and so how many inputs are there? Inputs you have one input and outputs, four outputs, and selection lines. We have four selection line and one enable pin. So from this, I can say that like this is a 1 cross 4 DMux. This is nothing but 1 cross 4 DMux. 1 cross 4 DMux. Okay, 1 cross 4 DMux. So 1 cross 4 DMux, active low enable, active low enable, active low enable, and active low output DMux. Active low output. So active low enable, active low, output demux, demux. So how to draw the truth table like this is the demux. D option is correct option. So this is a demux, demux. So how to draw the truth table like enable, enable, and the selection lines S1 and S0, and next Y0, Y1, Y2, Y3. So here when enable pin is 1, whatever may be the selection line, you are getting the outputs as inside zeros only, okay? Or don't care, so we can call as don't care. Okay, enable pin is 1, or it can be active high also. We can call active high also. So whatever may be this S0 and S1, you are getting our output as 1. Enable pin is acting as a switch. So when enable pin is 0, this demux will be activated. So combination 0, 0, 0, 1, 1, 0, 1, 1. So here when it is 0, 0, this is D and remaining all are 1. And when S1 and S0 are 0, 1, Y1 is selected to the data input is connected to the Y1, and remaining all are 1. So this is 1, this is 1. Okay. And when 1, 0, so data input is connected to Y2 and all are 1. And Y1, data input is connected to Y3. So like this, we can analyze. Okay. And next we'll see this problem. What is the logic circuit represented by figure shown below? Okay. So this is nothing but A bar, and this is B bar. So this is A bar, B bar, and this is AB. Okay. This is given to OR gate. So this is A bar, B bar plus AB. You know that A bar, B bar plus AB equal to what? A XNOR B. XNOR B. So this is XNOR B. This is XNOR B. So that means it will be like this. XNOR gate. So this is A and this is B. Y equal to A XNOR B. Y equal to XNOR. So what type of logic? Okay. And okay, both are same. Both are same. Okay. And next, here if you see, so these are the inputs, two inputs given to XNOR gate. First, we will draw the truth table for XNOR gate. XNOR gate. Truth table for XNOR gate. So both inputs are same. The output is 1, and both inputs are different. The output is 0. That is the truth table for XNOR gate. 0, 0, 0, 1, 1, 0, 1, 1. Okay. And next, so here this is 1, remaining all are zeros. So here I will draw the timing waveform. So that means see here. So this one, and here I am drawing, and here I am drawing, and here I am drawing, and here I am drawing. Okay. This is 1, and this is 0, 0, 1, 0, 1, 0, and this is 0, 0, and this is 1. This is 1, this is 0, this is 1, and this is 1. So I'm drawing that color. Okay. So see, so when it is 0, 0, it will start from 1. Right? Because I'm seeing the truth table. When both are 0, 0, the output is 1. And when it is 1, 0, the output will go to 0. Okay. And if it is 0, 1, output will go to 0. And here 1, 1 means again the output becomes 1. And 0, 0 means the output will be 1 only. 1, 1 means the output will be 1 only. And 1, 0 means the output will be 0. Okay. So that means output D is satisfied. And the answer is A. Option A. Answer is option A. So option A, it is satisfied. So that means option A and output is D. Okay, somebody will confuse that this is D, option D. Not like that, just option A. So which is satisfied means output D. So these are the questions related to the uh, combinational circuits and as well as logic gates. Hope you understood. Okay, thank you.